This theme of integrated management of the various elements of the system, because we were driving the design for this multi-purpose launch pad, we were able to get our design requirements in early, and that allowed us to drive requirements on the fuel farm, and it also allowed us to influence the control system. And we actually came up with an integrated control system that we called it the Orbital Commodity Control System, and that was basically an Orbital built ground support system with software and hardware that interfaced with the Mid-Atlantic Regional Spaceport. The spaceport basically an interface to their industrial controllers. So you can think of a control skid with pumps and pressure transducers and valves, and our control system was layered on top of that, where we could turn on this valve or read that pressure and have that knowledge in the control system. And then that control system was extended out and interfaced with the rocket to an umbilical. And so that's how we achieved that coordination piece between the ground and the rocket, was through this integrated control system, the OCCS. And I think that was very effective. It allowed us to do this sequence of events, and we actually created an automated sequencer that starts at the opening of the checklist, and it flows right through the timeline, and everything is timed on that sequencer. And so it's basically our operators are monitoring, and they can intervene if needed and make manual changes. But if everything's going well, then that sequencer just chugs along and controls the ground and the necessary stage 1 control elements, the valves on the vehicle, and that's how we've mechanized the whole loading sequence, and as well as the detanking sequence if we have a scrub on launch day. So that's very effective to have that all under our design cognizance as well. Talking about the development of a new liquid fueling facility and a launch pad capable of launching a medium-class liquid rocket from Virginia, where Virginia had only launched, the biggest thing it had launched from there was a Minotaur, basically a small launch vehicle that was all solid. And it was a big shift, and we went into it thinking that we had scoped the effort. We had some estimates that we had paid for from Reynolds Smith and Hills and others. Reynolds Smith and Hills is a contractor, architectural design firm that has built many of the pads at Kennedy Space Center in Florida, and so they're located in Merritt Island, Florida. We brought them up to Virginia to give us a look-see and tell us what it would take to build Pad 0A at Wallops. We had the Mid-Atlantic Regional Spaceport also advising us, and in the end we were completely wrong. We had totally underscoped the effort in terms of the cost and the time it would take to build such a facility. And part of it was just not having the rocket designed yet. We didn't yet know all of the services that would be provided necessary to fuel the vehicle and get it ready for launch. And we just weren't that far along to where we could say, okay, the helium that's going to pressurize the propellants. I mean, we knew that we would have a liquid oxygen tank. We knew we'd have a kerosene tank. That much we knew. But we didn't yet know, okay, the pressurant gas, the helium that was going to pressurize those propellants and force them down into the engine. We didn't know what pressures those needed to be, what temperatures they needed to be, what flow rates, and so on. And that came later, and that ended up, driving some of the design considerations. But frankly, we just had underestimated the scope from the start. Both us and Mars, our partner in the Commonwealth of Virginia, and it just took a lot longer to get the design complete to where we could agree that this was going to work, to get the funding in place, to get the construction mobilized, to get all the necessary permits and approvals, and then just to get the job done and then test it adequately to prove that it was going to work. And I would say the liquid fuel farm is the most challenging aspect. The launch mount itself, with this metal and concrete and a flame trench, well, that's a bit simpler. But and the water deluge that goes with it. But the intricacies of the liquid fuel farm, how the fuels are going to flow in, it's so integrated with the launch vehicle. When you start the flow of liquid oxygen, you first have to have the tank conditioned for that. You don't want any air in the tank, so there's usually a ventilation process or other that occurs first using helium. Well, that whole sequence of events, I'm going to turn on a valve on the ground. Well, I've got to have a valve on the rocket turned on ahead of that, and the vent valve has to be open, and so on. And all this coordinated activity requires a whole orchestration that I think we had underestimated. And so that ended up driving our first launch date was the completion of the launch pad, and in particular, the liquid fuel farm. Since that launch, the pad and liquid fuel farm have worked very well, been very repeatable and reliable, and we're learning lessons each time. We're increasing robustness in the system, and last couple operations have been very smooth. What would have helped us get through that pad development project quicker or better? You know, I think you almost need your own people that have experience with that exact process. But if you think about in the United States, when was a brand new liquid launch pad actually built from the ground up? You know, for example, you know, SpaceX inherited the Titan IV pad. There's a lot of reuse of pads and so on at Vandenberg that Delta has been able to use and so on at Delta IV. So from the ground up, there's just not a lot of experienced personnel out there. We did look for you know, some of those folks, and we were able to hire a couple that did help us. And but in the end, you really need that. You need to, you know, kind of bring that capability in and have it there from the ground up. Hire the right folks that are gonna bring that prior expertise. We were able to do that a little bit. I'd say, you know, we could have done that more. And you know, we did lean on Kennedy and some Stennis folks to help us work through some of the problems. NASA brought them up to help us with their expertise. But you really, that's not the same as having somebody in-house with the authority to commit the company and to make design changes from the beginning of the project.